Welcome back to Electrical Power Plus. In this video, I will explain how to create an Omicron Control Center file. The Omicron Control Center file, usually called OCC file, and its extension file type is .occ. The Omicron Control Center file is used to do the testing automation. Instead of manual testing, Omicron Control Center file .occ is an automated file that is prepared to save the time in the testing. So let's see how to create this file. This is Omicron Control Center window. I will close and I will open again to show you how to open this. First, we need to open Test Universe. So I have Test Universe version 4.4. If we open Test Universe version 4.4, such an interface will come. These two documents are Omicron Control Center files. This is to open the existing OCC file, and this document is to make new test document. So first we use this document and see how to create .occ file. This is the front interface of Omicron Control Center. Here, what we have by default is test 1, and inside this test, we have test object and hardware configuration. The test object is the relay which we want to test, and hardware configuration is the configuration of our test set which we are going to use. For example, CMC 356, as you can see here. So here we have 1, 2, and 3 other options. Insert, here we can insert new test object, hardware configuration, test module, and group. And the text is used to edit this report. This Omicron Control Center is like a Microsoft Word. So next is View tab. So in the View tab, we have different views: list view and report view, script view, full view, and side by side. Now, for example, if we want to test the overcurrent relay, what we do? First, we insert a group. We will insert group from here. Okay, it will come if we make it out. Okay, this is our group 1. So we can name it by right clicking and going to properties. We can give name here, overcurrent, and earth fault testing. You can see the name we give is appear here. Now this group is empty. We create this group to accommodate different protections and test modules. As we give name overcurrent and earth fault, so it means our overcurrent module or earth fault module will come under this group. This is to combine these two. So what we will do now, we will insert a test module from here. So first we click here and then we insert a test module. Different test module come here. For example, advanced power, advanced transplay, auto recloser, AC/DC configuration, differential, and distance. All this. So if we want to test a overcurrent relay or overcurrent protection, we will select overcurrent test module. Click and OK. It will come here. So we can rename it overcurrent stage 1 and stage 2. If we have two stages of overcurrent in our relay which we want to test, so we will test like this. It's only the name to show that the stage 1 and 2 will be tested in this module. Now it's clearly showing the stage 1 and stage 2 will be tested under this module. If we not give the name, we cannot make sure that which testing is in which group. So naming is very important. So now we will create another module which is for earth fault. So we will again insert another test module. So this test module we will rename it to use for earth fault stage 1, earth fault stage 2. Press OK. So it will come here. Now first we go into overcurrent stage 1 and stage 2. We will double click it. This interface will come. Now it's an overcurrent module. So you can see Omicron overcurrent module is open now. Here we know to test the overcurrent there are two testings. One is pickup and drop off test and other is characteristic test. Characteristic mean which characteristic is we are going to use. For example, definite time, inverse time, IEC, inverse time. So normally inverse, very inverse. So we can give here and we can check its timing test here. So for pickup and drop off test we come here. Okay. Now our module is empty. Up till now we not insert any test settings. Any pickup and drop off value we not insert. So now what we need a pickup value and drop off value so that we give here pickup and drop off value and the same will be tested by using this file. So in order to insert the pickup and drop off value, we have two options. These two options I will explain separately. So what we do, we will go into test object. Here, the two options, out of these two options, first I will select first option, I will explain the first, and after that I will explain the second. Here you can see here it's overcurrent module, so overcurrent is coming here. Okay, but as you can see we have inserted, if I go back, we have inserted two overcurrent modules. I will close this. We have two modules, this for overcurrent stage 1 and 2 and other for earth fault stage 1 and 2. So the same we will do in the test object module, as I will show you. We go into test object. Here actually we have only overcurrent. So now we need another overcurrent module, one for overcurrent and one for earth fault. So what we do, we go into function and here is add. So all function, differential, distance, all function appear here and we will select from here overcurrent. As you can see, now overcurrent and overcurrent 2 appear. Okay, now you can see a difference that if I click here, this is blue, this overcurrent. Okay, but this is not blue. It means it's this module is not active. The active module are 1, 2 and 3. This fourth new module is not active. So when we will activate, because this module is for earth fault, so we will active in case of earth fault. How can we active? We can active by right clicking it and set as active function. We will click here and you can see our first module is inactive now and our second module is active. Like this, we can change this to our first function. Because now we are going to use overcurrent setting, so we will active this overcurrent function. We can rename it as earth fault and this as overcurrent. So now what next is, we will double click this overcurrent module and we will go into element. Here I need to test two different here I need to test two different settings, for example for one for stage 1 and one for stage 2. So what we do, we have add option. This is so what we do, we have add option. We will add another stage from here. We will rename this overcurrent STG stage 1 and we can rename this overcurrent STG 2. So let's assume, for example, in stage 1 we have the tripping characteristic of definite time. So we will select definite time here. Here we can select by double clicking any standard characteristics. For example, IC normal inverse, IC very inverse, extreme inverse. We can select. So, but we select IC definite time. Okay. Same by double clicking this, we can set the tripping characteristics. After that, the pickup value. For example, our pickup value is 1 ampere secondary. We will set here 1. This is editable. The same as for this. So now stage 1 is 1 ampere and we in the setting, for example, we have stage 2 5 ampere. So we will select here. As I will show you the setting documents. In the setting documents, you can see for 50-51 phase overcurrent, we have stage 1 and stage 2. For stage 1, we have 1 ampere pickup and for stage 2, we have 5 ampere pickup. Both settings are IC definite time. So for stage 1, we have 300 millisecond time delay and for stage 2, we have 100 millisecond 5 delay. So we will set this time delays and pickup values here. We will go back again. So here you can see we have time delay. So in this case, we have time delay of 300 milliseconds. And in the stage 2, we have time delay of 100 milliseconds. It's non-directional, so we will set here non-directional. After setting this, we can click on OK. Similarly, we will double click this. Here, we will set for earth fault element. So same, we have two earth fault elements at stage 1 and stage 2. So one element is this, and we will add another. Here we will name earth fault stage 1 and earth fault stage 2. For settings, we will refer to setting documents. Again, we will go to setting documents and we will see 5051N over current. It's for earth fault. So for stage 1, we have 0.2 ampere pickup with 300 millisecond time delay. And for stage 2, we have 1.5 ampere secondary as a pickup and 100 millisecond as a time delay. So all both time delay are IEC definite time. So we will set here IEC definite time. Okay. So IEC definite time, and the pickup value we can edit. We have not 1 ampere, we have 0.2 ampere, and here we have 1.5 ampere. This time delay is 300 millisecond, and this time delay is 100 millisecond. So okay, we can adjust its zoom in and zoom out. So now we will do okay here. Again I will close and okay. So what we do, what we have did already, we take one group, we put two modules, overcurrent module here, one for overcurrent and one for earth fault. So in the overcurrent we add two stages, stage 1 and stage 2, and the earth fault we added two stage 1 and stage 2. Now in overcurrent, again we will go okay, and we go into test object. We select this overcurrent elements, so both elements enable okay. So we should take care that this overcurrent should be active. So we'll make okay. So now what we have to do, now we need to add the test points. For example, in order to test the stage 1, we need to select whether either we want phase 1 to ground, for example red, yellow, blue, or phase to phase or three phase. So we need to add these test points. So for pickup and drop off, we will add uh, 7 points. 1 2 3 4 5 6 7. Why we add 7? We need to check the pickup of every phase, L1, L2, L3, sorry, L1 to earth, L2 to earth, L3 to earth, line 1, line 2, line 2, line 3, line 3, line 1, and line 1 to 3. Okay, as you can see, we set in the module setting 1 ampere, so 1 ampere will come here in the pickup. We not set the drop off, so drop off is not coming here. Okay, in the characteristic text we can check time. In order to check the time, we need to add the test points. So we can add test points from here. For example, first test point is line 1 to earth. Okay, here we have to work on stage 1 and stage 2. First we want to check the stage 1 timing, so we will select this. This is the factor mean how much current should the set inject to test the timing. So we will select 2 times of our setting. So 2 we will put here. Automatically it will calculate the magnitude. So as we put 2, our pickup is 1 ampere. So 2 times of pickup is 2 ampere. So it will come here. Okay, you can see t nominal delay, automatically take what we have defined. Okay, so now what we do, we will add. You can see it's added. Like this, we can add many test points. For example, line 2 to earth, line 3 to earth, L1, L2, L3. This we can check. So our stage 1 is completed. Now we want stage 2. As we select stage 2, you can see our T nominal tripping time change to 100 millisecond as we have already set. So what we do, we will inject 2 times. Okay, 2 times or 2 times mean actually the stage 2 pickup is 5 ampere. So 2 times of stage 2 mean 10 ampere automatically it will take. So first we add line 1 to earth, add, then we add line 2, then we add line 3, and then 3 phases. So now we've added all the test points for stage 1 timing, for stage 2 timing, and for stage 1 pickup and drop off. So what we do, we will exit and return to test 1. Similarly, same process we will do for earth fault. As you can see, here we go to test object, and here we go into this object. But first we need to active this object. Now this is for our alpha, so we will active this and we will double click, and what we do, we already have two settings. This should be checked. Okay, okay. So now, for example, we do, this is the earth fault. Okay, so earth fault, in the case of earth fault, we will only select line 1 to earth is enough. So you can see 200 milliampere pickup in this case. So for the timing test, similarly we need to add only 1 point. So we will add and we will select here stage 1, not 6 times. We need only 2 times. Okay, 2 times mean 400 milliampere we will add, and other for stage 2, 2 times mean 3 ampere because 1.5 is the backup for stage 2. So we will add these two. So we can exit and return to test. This is the one way we can use Omicron control center for testing. If we start and continue, the all module will be started one and after. But if we select a specific module, we can start and continue this specific module. The second way to continue, the second way to control, the second way to create Omicron control center file is by using XREO. By using XREO file, we can create an Omicron control center file. In this way, we not need to add the test modules manually. So the Omicron control center file by X. The second way how to create the Omicron control center file is by using file type XREO, and the method how to create Omicron control center file by XREO I will explain in my next video.